Observability, and again, thank you Risky5 for inviting me to be the guest speaker on your first event. I'm super happy to be here. First, a little bit about me. I'm ex a lot of stuff, so I've had many jobs in data engineering, software engineering, platform engineering. So when Risky5 contacted me, they were like, well, can you come up with some topics? And I gave them a few of them, and they were like, data quality. And I was like, data quality. But then I was like, oh Jesus, data quality is ginormous. How do I make that into like a half an hour speech? So I decided to do something a little bit more fun than being like super technical. So you won't be seeing examples. You won't be seeing live coding. You won't be seeing any of that. It will be approachable to everybody. That was my intention. And without further ado, let's jump into it. So I wanted to start with a quote because it makes things look a little bit more serious. And the first one I have for you is that data is the most precious thing and will last longer than the systems themselves. This was said by Tim Berners-Lee. If you don't know who that was, it was the guy that pretty much invented the World Wide Web. HTTP, HTML, URL, everything that you use on a daily basis and this presentation is running on was created by him. So I would say he's actually a smart guy, and I would say that the key takeaway of this phrase is that the data matters. But not all data matters, because you can have good and bad data, and the quality actually matters, and that's why we're here today. So the second quote is very famous: garbage in, garbage out. So if you treat your data in that same approach, you're going to have this, which is not that uncommon, which is in technology. And nowadays we have an even better one, which is this. So yeah, don't do that. Like, get rid of the first emoji. So that's what we're going to talk about today. And I wanted to make this an analogy, like I told you, because it makes things a little bit more easier to digest. And the analogy I decided to make was that data quality is not like climbing a mountain. Now, to prove my point, here's what is important for climbing or hiking. So it requires preparation and discipline. Like, if you don't have these, well, good luck. The second one is that progress happens gradually and requires cautious use of effort. Like, you need to pace yourself to hike a mountain. Like, if you try to go too fast, you get tired, you don't get there. So it is important. The third one is that every stage builds on the previous one. Like, if you climb a mountain, you learn some stuff, the next one is easier, or you're able to do a harder one. So it's always like this gradual improvement process in life. Then the fourth one is that skipping or rushing steps increases risk, and you can think of this as like the shortcuts. Right? Shortcuts in a mountain usually means you're climbing a wall of stone that you shouldn't. Probably should go around. It takes longer, but it's safe. So it's the same with data quality. Maturity and knowledge of the terrain leads to better outcomes. Like, if you don't know what you're working with, you're probably going to do wrong assumptions or run into mistakes more often than not. So it's the same thing, data quality in mountains. But still on the analogy, let's not forget that data quality is never the goal, or it shouldn't be. It's the mountain we're climbing, but your goal should be to have trusted data that can then be used as a strategic asset to generate business value. So that should be your goal, business value. And data quality is your foundation for it. Right, so what's our trip today? We have a long trail ahead of us, and this sort of like mimics the life cycle of a company, or at least the life cycle of the data group inside a company. And some of the things you will hear at the Valley are more like the startup phase of the company, and then you will see, and some of you will recognize that some of these mistakes are typical, they happen, and that's the whole point. That's the story that I'm telling to you today. So let's start at the Valley. Everything is green, super beautiful, we have the mountain in front of us, and we prepare to climb, but how is exactly the life down here at the Valley? So the usual problems at this phase is that you have missing ownership of the data scopes. You have lack of standards for data, which is funny all the time. You have 2 or sometimes even more business definitions for the same thing, or different ways to calculate the same thing or same metric. And you have more frequent than healthy manual data corrections. We all love to go and smash the database at this phase. And the results are low confidence, like people will be like not trusting the data because they know that there are plenty of issues in it. Low understanding, like because no one actually owns everything. Sometimes someone looks at it and it's like, how is this even possible? Constant firefighting, like those fixes are the typical things at this phase. So let's start hiking. Let's go to Basecamp 1, and what we will be trying to do is achieve some level of data sanity. So the climb begins, we're laying the non-negotiable groundwork, defining standards, and assigning key stakeholders to prevent the structural crumbling that we've been talking about. So, climbing, it's done step by step. And I've highlighted a few things which are important to achieve, and the first one is the data standards or normalization. Who hasn't seen this before? It's the same date. And some of them are ambiguous, so good luck parsing that right. So don't do this. This is the early phase mistake. If you have control over your data, if it's inside your scope, so it's not coming from an outside system, make sure that you have a standard for it. Like pick the first date as your format, and everything in every single database, in every single system should be that one. Stick to it. You're gonna thank me later. Yeah, so that's what standards are for. So that they're naming rules. I bet everyone has seen this one before. First team creates the database for the application and calls climber ID the ID of the table, right? The second team is like, they didn't look at what they had, they create another one. The third one is like, that is too long, let's make a short one. The fourth one is like, oh wait, that I can read that, so I'm going to create my own. And then you have migrations. So someone decides to label it old, and the other one is labeled new, and then someone later is like, oh, we need to rename new. To what? Oh, that one already existed before. Well, good luck, you now have 8. So don't do this. Stick with the name, use it all the time, and democratize it. Everyone should know that's the name for this. And we're going to talk about data catalog just in a bit, and that's related to it. So then data contracts and schema validation. Great example of like one field which has a meaning. It's already standardized, it's in meters. Fabulous, we don't have centimeters or stuff like that. But we have someone decided to insert the string, and it's possible. Well, good. Now whatever is doing the parsing, if it's not prepared to take care of strings as well, kaboom. We love kabooms. And then the same happens for the nullables. You have null, you have not a number, you have not a date, you have not whatever. Don't do that. Stick with something, define that's the standard, catalog what the accepted values are for that field, and then democratize it again. The whole company should know what to do with that. Talking about catalogs, another good example. Here I actually put some very bad names, but it wasn't the intention. Actually, the intention is let's just focus on this one, F001. Let's say that it's actually, like it's a feature in the product. So it has a meaning for the company. But if you just come in, or you're not working with that part of the product, you look at that field name and you're like, sure. The catalog is for you to have, this is the field name, this is the table where it exists. The owners are these folks, and these are the possible values inside that field, and the type is this one. If you do this and then democratize it, everyone will have where to go to read and know, well, that's the one I should be using, I know what it is for, now we'll use it right. Talking about ownership, and the best way to describe ownership is with this anecdotal situation, which always happens in startups. So the business comes rushing into the room, and they're like, folks, these numbers look completely wrong, and everyone is like, analytics goes like, okay, let's defend ourselves. Well, we just use the data. And engineering is like, pipeline is working just fine. And source team is like, we just extracted the data and it's there. Well, it's no one's problem. That's lack of ownership, and it becomes everyone's problem. Because if you have something that isn't owned, whenever you need to do a fix on it, or you need to find the issue with it, no one either takes care of it, or worse, no one knows how to take care of it. So ownership, define the scopes, all of the scopes, and find an owner for every bit of the scope. Last but not least, this is where it becomes specific. Like your system will also have what makes sense to it. And if you are at your early phase of the business, you should define what those are. So this is the climber system again, and this is one input in our database, where we have the age of the climber. It's 5. Pretty sure that's not true. Then we have this second field, which we check in the catalog, and means that this is the date that the climber first climbed a mountain. Well, pretty sure he's not alive anymore, because if you did it in that date, that's definitely not true. The second one is for, the third one, sorry, is for the last climb this person did. Considering that it is in the future, I'm pretty sure that's not true either, because it hasn't happened. So you should have validations either at the input phase, well, you should definitely have at the input phase, and then again at your storage level, making sure that these values don't make it into the stream of data. Why? Because someone is going to be building analytics with them, and there's a metric that it will be completely screwed by these bad values. So clean them as early as you can, if they even have to happen, because you can't avoid that. So yeah, long way up already. And we could talk about the sanity in 2 areas, but there's 2 sides to it. So one is like purely technical, is the rigorous validation part. So creating schema definitions, field constraints, strict data quality rules, which we just talked about, will ensure that you prevent the garbage from going into the system and make it all the way down there where you don't want to. The other is almost cultural, is that ownership part. Like if you have this intentional assigning of operational, business, and technical owners to all specific data domains, you will have clear lines of accountability, and then whenever there's quality issues, you have a fast resolution, or at least you know that someone will be appointed to take care of it, which is very important for your company to have some stability and not firefighting all the time. So what are our successes so far with these efforts done? So we have the standardized definitions, we have basic data quality automated validations, we have reduced the number of failures in ingestion, and we have understanding of what's in the data, and we have clear ownership. Very important achievements already. And with that, we reach the beautiful base camp 1. We set up our tent, and in the evening, we are sitting by the campfire, but we're still, well, things are better, but not all is well. And actually, this is actually the hardest phase. It's where things become arduous to achieve. It's not as simple anymore, but it's equally or even more important. And what are those problems that happen the most? Well, you did invest a lot on like improving your data with all of those manual fixes, but now you have guardrails, but you're still looking at it and it goes like this. And you're like, oh my God. Why? Because someone decided to put a new system, or there's a new part of the application which has slightly different approach, or introduces some new type of data, and that's causing that quality degradation. Then you also have the typical lack of observability, which is you have systems and pipeline failures that aren't visible. They occur silently. You don't even know they happen because you have nothing forcing them to be monitored or events being generated from them that will allow you to capture those failures. Another thing you will have at this phase is that the data issue detection comes from the feedback of the end user. And most of the time, it's that business that comes in and is like, what happened here? Yeah, that's not good. Try and avoid that. Number at the source don't add up with the destination, reconciliation problem, very typical of this phase of the company. Data deletion, someone heard of GDPR, and they heard of your company, and they're like, I want my data gone. Chaos. I'll tell you about it just in a bit. Latency, so it's going from, in this case, latency is referring from when the data is being ingested, so it starts the process, and reaches the analytical system, so it becomes visible to stakeholders. If it's too slow, it might compromise the value the business can get out of it. Like if it comes too late, you don't do anything useful with it. So that is a problem zone. And last but not least, but also very, very important, you notice that you have some groups which have access to the data that you probably should not have at all. So what are the results of this? Constant revalidation of results and data values, opaque systems and unpredictable impact of changes, and possible security issues. Let's try and address them. And we're going to do that as we build observability on our way to Basecamp 2. So as we ascend further, we're moving from structural validation to systemic monitoring, reconciliation checks, and scalable pipeline observability. All right, the steeper part of the trail. So let's start with reconciliation. Reconciliation, explaining a very basic example, is like you have checkpoints, or you have final and end state, and you look at numbers. And this is a perfect example. 10 climbers left camp 1, 10 climbers arrive at camp 2. How often does this go this way? Almost 0 times. Because there's always something else. So in this mix of pipeline monitoring, which I'm about to explain to you, you have 10 which left, 8 that arrived. So you have 2 missing. Yeah, well, first of all, this is not all bad. You could have it reversed, and then it's like an impossible state. Also happens. But like, okay, we're still missing 2. So you probably need to figure out what other things might happen to your data points to make sure that you track those things. And for example, we have giving up. Giving up is an option. When you get tired, you exit the mountain. 2 plus 8 equals 10, last time I checked. AI might say otherwise. But it is how reconciliation is done. But think now multiple formats of data, and like all of those things you can do. It's not just simple numbers, but that's essentially what it is, reconciliation. Right, so observability and basic visualization, the best way to explain is think of some typical metrics. And metrics are usually categorized in a few things, and these are parameters of those metrics which matter. So freshness is quite often mentioned, and for our example of the climber system, we have the last ping from each climber. So the last time we received a ping from their tracker will give us a measure of freshness of our data. Then volume, think of like the number of climbers in the mountain, how many are there, how many entered, how many exited, those are all volumes. So it's usually the kind of stuff that you try to put on your observability layer. You have graphs for this. And talking about graphs, distribution is usually seen through visual bar charts or other types of that. And it could be to answer the question of where are the climbers in the mountain, and you see it, a bar chart, the distribution all over it. Failures is what usually matters the most, especially to the tech side. So how many people fell, how many requests for assistance did we get, how many trackers did we notice are not working. So those are all failures of the system or the data points inside the system, being the climbers in this case. And that's what more or less observability is built on top of. Graphs for all of this. So lineage was mentioned just a while ago, but I'm going to introduce lineage again in a very basic manner. So you might know that the climber started at the valley and he's currently at base camp 2. So that's initial state, final state. And you know that it carries 1 liter of water and 2 granola bars with him at this point, so at base camp 2. But there might be some use cases where you need to know how it got to that. So it's the history of your data point. So you want to know like that 1 liter of water, how much was it at the beginning and where was it actually consumed? That's what lineage is. It's very important for a bunch of use cases. It's very important for systems to be well monitored. So that's why I put it here in this phase of the graph. Right. Automated alerts, it's when the fun actually starts. They're usually basic. That's why I put it on this phase and not the most advanced ones, which I'll mention later. But one example would be climber looks lost because you see the tracker going around in circles. And then the rescue team does see that data and is warned and then get in contact with the climber to tell them, oh, okay, you seem lost, you need help. So it's an automated alert in this case. SLA and SLO tracking, this is quite common for any tech company, more or less nowadays. You need to uphold your service level agreements and all of that. And one example would be for the climber system, you have your rescue team, and the rescue team has to always respond under 2 hours. So what do? You track the response time, you keep all of those data points, and you build your graph, and you keep it in check. You cannot go under it, so you track it. So about the ingestion, I did talk about the latency. I did put very clear, as fast as the business needs. Don't forget this. If you go the other route, you over-engineer. Like if the business needs climber location at least once per hour, you're not going to do every 15 seconds, because otherwise you're going to accumulate massive amounts of data. You're going to create a system that is expecting a massive throughput. For what? Just to pay more. If you're expecting, oh, they're going to change their mind, they're going to want like every 15 minutes, sure. That's 4 times per hour. It's not 1 time per minute. So don't go that way. Like, stay close to that. Maybe think of the system if it will scale if the requirements change, but don't go crazy with over-engineering. The other part is I mentioned DRY, which means do not repeat yourself. This is usually more seen on the code side, which is that good practice of not writing the same thing if you can just share it with other use cases. So for data, it's slightly different. It's think of like data can actually have 2 different meanings but leads to the same conclusion. And I gave an example with 2 events. So the tracker reports that the climber exited the mountain. The rescue team reports that the climber was extracted. These 2 things mean different things, but for the system they are the same, which is 1 left. So you have to have processes which are capable of taking care of these different events and then correlate to the right metric. Never add them up, otherwise you have an amplified signal or a wrong calculation. So think of that every time you design events, especially, is how you actually take care of them in your backend or warehouse. So about governance a little bit, I put data privacy and data retention or deletion or the 2 in the same bucket. So one example is like your junior engineer is like playing around with the Beaver and it does a query for a climber ID 123 and you can see all of this data. Do you think that's okay? It's not. Like he's seeing a lot of PII, so address, phone, full name, and he also has access to protected information like previous health issues or the health insurance policy. That shouldn't be accessible by a junior engineer, and this is a clear problem with security. So define policies to prevent this. Data access should be by default no access. So no one has access to anything. And then you set up the ones that should have access to something, and you give one by one. Not the other way around, because otherwise something will fall out of your view, and then you lose track of something that slips out. And that's a problem, and it could be business ending at times. That's how data leaks happen. So that's pretty much it. Now for the deletion part, like I did talk about that GDPR, remember? So the request comes in and someone says, well, we're gonna have to delete everything about climber 123. And all of the data needs to be gone from our system. And the result is that you have 5 teams that have to delete stuff. They are asked to do this and they say we need 2 weeks. And in the end, someone is like, oh, the metrics dashboard is now broken. This is such a common example. This happens more than half of the times. Things were designed not the thing to get rid of data completely, or to expect that data will become out of sync, either because the versions change or because the data becomes irrelevant for the process, and they don't think of that. So retention and deletion, if you can design early to take it into account, it's very important. Otherwise, we will go into this pain sometime. Right, a lot of pain, just like climbing, but we got somewhere. So we have 3 areas of what we just did, and what we just did is actually a positive movement from going from tell me to show me. So before, someone would come to you as like, tell me this about the data. And now you go like, here, I'll show you this in the day. So you've achieved a little bit of that already, and that's very valuable for the trust that people will have on the data team, because you will be able to show reliably what people need to know. So there were 3 areas which we focused. Reconciliation, we talked right at the beginning, and you now have constant validation between the source systems and the analytics, and you are ensuring that mathematically and conceptually it is as expected. That's important because you can now trust that. The ecosystem monitoring, so you put events all over your apps, all over your pipelines. You have tracking of that pipeline health, freshness, volume changes, execution runtimes, and this allows you to surface anomalies before the end user comes to you. So you start being the one that knows of it before everyone else. Very important. The governance part is where I talked about the security. So by defining the automated policy enforcement, you create this deep organizational trust in the safety, the retention, and the deletion processes, which is important for the data group to be trusted again. So it's all about trust. So what does the success look like? So you now have end-to-end observability, you have lineage, you're capable of performing easy impact analysis and root cause investigations, you have strict and clear data governance policies, and you have that auditability and compliance support which your business at this phase is starting to bang the drum all the time because they need to be able to show that they are at that phase to get some wins as well. And we reach base camp 2. So the green is gone, we have the mountain right in front of us, and now it's actually not about problems anymore, it's about needs. So BC2 onwards is for greatness. So we're going for the big wins now. So what are the needs that the people are coming to you with? Is that stakeholders complain about the lack of visualization, they don't have vision to everything, or self-service. Like the data exists, but they don't know how to get it. They can't do it by themselves. The business wants to develop complex algorithms. That's where you start hearing about AI and you know that you are actually ready for it. It's not at the beginning. Getting rid of a few remaining manual processes is still important. Like you have some stuff which people still do. It's done manually because it comes from legacy. Happens, nothing wrong with that, but you're spending money on it. That's the problem. So what are the results? We have the DA group, data analysts, that spends more time answering business questions than preparing them the tools for them to answer themselves. So it's just a loop. Like you need to invest for them to create the tools, but if you stop that, then they cannot answer, so you need to get out of that loop in this case. Money is spent on legacy BAU, as I mentioned, so business as usual, so you still have some processes which are manually because you don't have the time to invest on making them automated. Right, so let's start this third phase of the hike, and we're gonna hike to the base camp 3. And our intention is to extract intelligence from our data. On our way to the peak, we're leveraging our rock-solid foundation to drive business growth, predictive automation, and strategic ML and AI initiatives. So I divided the big wins, let's say, in 4 groups. And I'm going to start by the predictive analytics. And the best way to explain what predictive or forecasting analytics are is to say that it's the shift from knowing what happened before to shift to what should happen next. So you're trying to predict based on what you know and based on what you've seen happen in the past. So a very good example is you have this use case where you want to not over-provision your rescue team. So you don't have to have like 4 helicopters because sometimes you need them. And they're all filled up and you have all the teams ready to jump on them immediately because you need to keep that SLA perfect in place. So how many rescues should we be prepared to take care of tomorrow? And how do you do this? You know the weather, you know how many happened, you know how many people are in the mountain. All of those values will contribute for you to be able to estimate and predict. Do you get it right all the time? No, but that's how you know. Slightly over provision, but anyway, it's a valuable thing to have in your business, most of it. Right, Second area is the advanced BI, business intelligence, and visualization, and that's self-service analytics, which people are crying for today. So there is this very famous phrase of one image is worth more than 1,000 words. For you, the data, it's slightly different. It's one image is worth more than a lot of data sitting in tables. Why? Because if it's in tables, well, you probably can read this. But if you're from business side, maybe this is just funny words, but this is a query. Now you know how to do it. If you're from the tech side, they don't. So you create tools so that they don't have. And in the recent past, there's a lot of tools that showed up for dynamic dashboarding, natural language queries, and even AI stuff that allows you to export the data reliably. So this is when you put it in place, because you will allow the business to interact with the data, to get the answers, to be self-sufficient, to make fast decisions. This is very cool win to get for every company. Right, so machine learning and AI applications. Everyone is doing their learning. So for our use case here at the Climber system, on real mountains, there's these guys called Sherpas, which are like super knowledgeable. They've done the climb 1,000,000 times. They know where the dangers are. They look at the cloud and they say it's going to rain there. It's crazy. But if you have a lot of data, you can actually replicate what they do. One idea is you create the Sherpa AI, which is a model capable of giving climbers advice on what routes to take and warn them of dangers in the road ahead. And they have them on their phone, they climb, they ask questions, they decide what to do. Cool use case, but yeah. Last but not least, intelligence decisioning. I love this part of what you can do with data. And one example is like you have this situation, weather is getting dangerously worse. And what's the system reaction? Well, it probably knows from previous data that it might rain, downpour like crazy, it's going to get muddy, people will slip and fall, you're going to have to call all your rescue teams. So to try and avoid it, you make a decision. The system decides by itself to automatically reroute the climbers or tell them to turn back completely, because we know it's going to be chaos. So they get warned, they do that, great. You avoided a possible very complicated situation in your system. That's what intelligent decisioning is used for most of the time. Right, we reach base camp 3. It's right there in the middle of the icy bits, and you're looking at the peak right up there. We reflect. What have we achieved? So our data is trustworthy. We have continuously monitored data and systems. We have governed and secure data. Accessible and understood by everyone in the business, because you've created tools for everyone to explore it, and play with it and get answers from it. And last but not least, you are comfortable saying that you safely support automations and AI on top, because you know you got rid of that emotion. So now they're doing like real unicorns. Cool. That's a lot of achievements, but what about getting to the peak? Well, getting to the peak is up to everyone else, not to me. So the peak is where the value is. You can build, monitor, improve, and you reach and grab it. So please enjoy the climb. And before I finish, I want to just do one final quote, because why not? And this one says, the organizations that treat data as a first-class citizen and data quality as a strategic matter, not technical debt or the technical problem, are the ones that unlock the real business value from it. And this was said by this guy, which I don't know who he is, but I thought it was good to finish the speech today. And without nothing else, does anyone have questions? Yes?
It's a technical question. Have you traveled to Everest?
I wish. Not yet. But there's actually photos that I took from other mountains, and there's photos which are not from the Everest in this presentation. So just out of curiosity, I really like hiking, so that's where the analogy also came. Thanks for asking. Any other questions? No? Okay. Thank you very much.